Hey Brian, I was tasked with finding out if our 24-inch Platinum Snow Throw could throw snow at least 40 feet. One of our competitors is marketing that as a feature, and we want to be at least that good.
Huh, that doesn't sound too hard. What information do you think we'll need to solve this problem? We can use one of the projectile motion formulas to calculate the range of the snow. The range R is how far the snow will be thrown in a horizontal direction, which should be at least 40 feet. As you can see, the range R is shown as the horizontal distance that the projectile travels. Before we can calculate the range, we need a few things. Do you know what they are?
We know the snow is guided out of the snowblower from the chute. The chute must have an angle on it, which would be angle theta from the projectile diagram. I should find that angle.
That's right.
I looked at the snowblower and determined that the chute angle has an exit angle of 51 degrees.
The formula for the range R of the projectile is R equals u squared sine 2 theta divided by g, where u is the exit velocity in feet per second and theta is the exit angle in degrees. I hope you know what g is. We're working in imperial units.
I know I'm green, but not that green. Come on. The gravitational constant in empirical units is negative 32 feet per second squared.
Correct. We refer to it in the negative because gravity pulls on the snow in a negative direction. However, for our calculation, we'll use the absolute value of g. So how do we find the exit velocity of the chute?
The snowblower is a fan, which sets the velocity of the snow coming out of the chute. The owner's manual lists the fan speed at 68 feet per second.
Great. We'll use 68 for the value of u. It looks like you have everything you need to calculate the range. Let's see what we get for a distance.
When I plug in 68 feet per second for the velocity and 51-degree angle on the chute, I get a range of 141.3 feet. I don't think there will be any problem saying that we can meet and exceed the 40-foot throwing range target. But there's still something that's bugging me about this.
What's that?
I've used a snowblower before, and the snow doesn't travel anywhere near the 140 feet. Why is the calculation telling us that it can?
That's a great question. Do you think the fan speed of 68 feet per second that's published in the owner's manual is loaded down with snow or unloaded?
Probably unloaded.
Right, unloaded. Since the snow can have so many different densities, the unloaded value is the only consistent way to rate the speed. So what do you think happens to the fan when the snow is added?
The fan slows down. Now that you mention it, when I blow heavy snow, I can hear the engine slow down.
Right. The engine is working, so the fan is going to slow down from lifting heavy snow. The fan slows down by approximately 30%. What else is happening when we clear the driveway?
The snowblower is moving.
That's right. The wheel drive slows the fan down by another 10%. What is the third thing that we have to account for?
I don't know. These first two things make sense, but I don't know what else we are missing.
We also have to account for the air resistance. We approximate that it reduces the range by an average of 15%. Okay, let's calculate the modified range with the losses.
I recalculated the range with the modified fan speed, and I get 50.9 feet.
Good. Now we need to account for the air resistance.
Once the snow encounters air drag, we estimate that it would reduce the achievable range by 15%.
All right, so what's the new calculated range? Would we still be able to achieve the 40-foot range we need?
All right, using 85% of the 50.9 feet, we get 43.3 feet. Hey, looks like we beat our competitor's throwing distance.
Nice job. I think we can take these numbers to marketing and tell them that it's safe to say that we can meet and exceed our competitors' claims.